wait for the writing pad to open.
No.
What do you mean, no?
What's the right mind?
Stop accusing me of things I didn't do.
Leave the poor Spanish boy alone. Just because his country has a terrible rugby team doesn't mean you can pick on him.
We're actually quite good in rugby, so.
Are you? Are you really? I'm not sure about that.
We are.
Really?
Yeah, rugby 7.
Really? Okay. It's good to believe, I suppose. Right, number 4. Number 4. Harry, could you read number 4 to us, please?
Determine the energy stored on a 18.6
Microfarads.
Like this, Harry?
Yeah.
Harry, like this?
yeah,
Yeah, okay. 13.6 microfarad.
15.6.
15.6?
Yeah.
Okay, 15.6. Let Harry continue there. Go ahead, Harry.
15.6 capacitor when it has been chopped to a PD of 15 volt.
15.
15.
Oh, 50 volts. Okay. Okay. Sorry, what do they want? Determine the energy?
Yeah.
Energy, right. So, Harry, the formula you should use here is a half CV squared. So that would be 15.6 over 2 times 10 to the minus 6 times 2500. What is that? 0.0.
1.95 times 10 to the minus 2.
Okay, but is that 0.0195, is it?
Yeah.
Joules, which is 19.5 millijoules. Okay. Is there a next part, Harry?
Yeah, the capacitor is then connected across a 3.33 million metal.
2.3, did you say?
Yeah, 2.33.
3.3.
Oh, 3.33. 3.33 mega ohm. Okay.
Resistor. Determine the discharge current after a further 30 seconds.
So they want the current after 20 seconds. 30 seconds. So the current will be I0 E minus T, which we know is 30, over tau. And we know a formula for tau, it's RC. So the R, well actually, do you know what, I better work it out here. Let's just put it here. Tau is 3.33 times 10 to the 6. Oh, this is nice because then the 10 to the, oh no, it doesn't. 3.33 times 15.6 because the mega and the micro cancel. So what's 3.33 times 15.6?
51.95948.
So our problem is we need to get I0. Now I think the way we can do this is because the capacitor, yeah actually, so this is an important piece of information. So if you have your capacitor, there's your capacitor, and you take a battery, let's say this is the battery, and the battery is 50 volts, and you charge this up, and then release, this will be at 50 volts at the beginning, and then it decreases. Yeah, so if you have this formula, V0, I0, or 0.
V0 is.
V0, we actually want I0 really, yeah. I0 is V0 over R0. Well, this doesn't change. So it will just be 50 over the R. So if I just continue this down here, this will equal 50 over 3.33 times 10 to the 6 times E power minus 30 over 51.948 equals. Micro? amps. That's pretty dang small.
Yeah. Well, this 36
True, that's a long time for a capacitor.
to discharge.
Yeah. Although,
It's already touching zero.
okay, whatever. If that's the answer, that's the answer.
Is that what you want?
Yeah.
Where's Lynn? No, don't know. Okay.
Maybe
Is that okay, Harry? Are you sure? For sure?
Yes.
Okay. We'll do 415 next.
No, this one has heat and steam.
Yeah, I know. Blowing your mind. I've been watching a lot of reruns of Rick and Morty, so I just really feel the urge to say things like, whoa, whoa, duck, duck. Pickle Rick.
Almost stopped watching it yesterday.
Season 4 or season 1?
Season 1.
Season 1, okay. Alright. Can I scroll down?
Yeah.
14. Right. Go for it, Harry. What's 14?
15.
Oh, 15, sorry. What's 15?
An electrical heating element has a power rating of 2.5 kilowatt. It is used to heat a tank containing 3.18 kilogram of water. Initially, at a temperature of 18.4 degree. Assume that the efficiency is 1%. It means the electrical energy used in raising the temperature of the water to its boiling point of 100 degree and turning 1.5 kilogram of this water into steam.
Wow. So there's a lot going on here. You have 3.18 kilograms of water at 18.4. You have to heat it up to 100 and let some of it become steam.
1.5 kilograms.
Oh, 1.5 kilograms.
Yeah.
Yeah, it becomes steam.
Oh, that's a lot to waste of steam. Okay, so power equals work over time. And what did they want the time, was it?
Electrical energy.
Electrical energy used.
So work.
Oh, so they don't care about the time?
Part two is the time.
Oh, part 2 is the time, okay. So the work done will be mc delta theta plus ml. Okay? So that would be 3.18. What do they use for C? Is it 4181 or 4200 or
420.
4200?
10
And then 100 minus 18.4 plus 1.5. And what's the latent heat of fusion?
Evaporation of water.
Yeah.
2.26 times 10 to the 6.
Okay, so simply bashing that into the calculator gives you the work done. Six, yeah?
4.18 times 10 to the 6 joules.
So now we can get the time. That seems... Okay, let's see what the time is.
1,791 or 92 seconds.
Divide that by 60, please.
Oh yeah, sorry.
No, I'm just curious what that is in minutes.
30 minutes.
30 minutes.
29.87 minutes.
That seems shockingly long.
Well, it's,
Not- What's this?
it's quite cold and it has to boil a kilo of water.
I suppose, but from my experience, water at 18 Celsius, you know, that's roughly
Yeah, tap water.
tap water. And 3, well,
3 kilos.
3
No, okay, 3 kilos I guess is a lot, since most electric kettles would only hold,
Like 700. Oh no, they were like 2.
they wouldn't hold 3 litres I don't think. Oh no, they
1.7.
might. They'd hold 2 litres.
Or 2 liters for sure.
Hmm?
2 liters for sure.
2 litres for sure, yeah.
That's like 1.75.
Sorry.
I think what is adding to the time so greatly is that you need half of it to boil away as steam.
It does. If you put like the
Hot water, I'm
Water,
thinking,
it
yeah, it'll take, maybe half an hour for half of it to evaporate. Yeah, okay, I guess that's, if you think about it as a cooking example, I guess that's reasonable. Okay, is that okay, Harry? Yeah? Yeah. Was that okay, Gina? How many did you do last night? 15, so you got this one?
No.
No? Oh, you have a slightly older page because I deleted one of the questions. So hour 15 was the old 16. You might have to refresh the page. Any of you guys use Windows 10?
Yeah.
I'm in huge trouble with Windows 10 at the moment. A lot of my window apps, like the built-in window apps, they won't open. Yeah. It's like they're not installed. You know, like Photos or Mail or whatever. The built-in window apps. They're all like blacked out.
On your new computer.
No, well, the old computer was only like 2 years old.
Blacked out as in you like the icons and the
Yeah, the icons are like half black, like faded.
I think usually that means that they're trying to be updated.
I know, I keep updating, and every time I try to update, at the very end of the process it says rolling back changes, not updating. It's like it's something causing it not to update. Any ideas? Huh?
I don't know, I've never encountered this problem before.
No, neither have I. It's like something is stopping the computer
Yeah.
updating. I can't understand it.
Can try resetting.
I don't really want to go to that extreme because it should just like it shouldn't just spontaneously break like this. You know, I don't know. Windows kind of annoys me sometimes with stuff like this.
Maybe it goes
Like
down.
this operating system here is, it's not an old laptop, but I find this much more stable than my Windows laptop at home, my Windows computer, because it doesn't do weird things. You know, it's not like I suddenly turn it on and all the icons are black and you know. I just have to figure something out. A lot of people on the forums were saying that they have to take it into a Windows store. I don't want to take it. I don't want to take the computer into a shop to get it fixed. It seems excessive. You know, I'll have to keep researching them. Okay, any other questions on this? No, we're happy with this? Yeah? Dorian, you watched the full video. Was everything okay yesterday? Yeah? Okay, so. I wonder if Lynn will watch this later.